Distinguished guests, ladies and gentlemen, good afternoon. Welcome to 2018 COMPUTEX Forum. This afternoon's program will begin here in about 5 minutes. Please be seated. Once again, please take a seat. This afternoon's program will begin in a few minutes. Thank you. Ladies and gentlemen, welcome to the 2018 COMPUTEX Forum. The theme of this year's forum is ubiquitous intelligence, and the forum will include 3 keynote sessions: artificial intelligence this afternoon, and future trends tomorrow morning, and IoT tomorrow afternoon. And this afternoon's program on AI features a stellar lineup of speakers from NVIDIA, ARM, Google, ADVANTECH, Supermicro, and the National Taiwan University, just to name a few. So ladies and gentlemen, to kickstart this afternoon's program, let us invite Mr. Walter Ye, President and CEO of the Taiwan External Trade Development Council, TAITRA, to deliver his welcoming remarks. Let us put our hands together and give a very warm welcome to Mr. Walter Ye.
Honorable speakers, distinguished guests, ladies and gentlemen, good afternoon. On behalf of TAITRA, Taiwan External Trade Development Council, 外贸协会, organizer of COMPUTEX Taipei and the COMPUTEX Forum, I would like to welcome all of you to join this artificial intelligence section for our COMPUTEX Forum. AI has continued to be the major driver of digital transformation in 2018. AI significantly affects manufacturing operations, business strategy, customer interaction, and workforce. It also further emerged into our daily life, such as the application of AI in autonomous vehicles, healthcare, service, robotics, and so on. It is believed that AI holds tremendous possibilities, opportunities, and abilities to improve our daily life. Today, the COMPUTEX Forum is honored to welcome 6 highly distinguished speakers from leading companies and research institutions. They are ADVANTECH, ARM, Google, National Taiwan University, NVIDIA, and Supermicro. All of these industry leaders who specialize in the field of AI will share the latest insight and applications. I believe what you are going to hear will be amazing and very beneficial to all of you. Before I give the floor to Mr. Deepu Tala from NVIDIA, I would like to wish you all an extremely interesting, informative, and enjoy afternoon. Thank you again for visiting COMPUTEX, and we welcome you to visit COMPUTEX start from today at all the venues here in Taipei, also Nangang Exhibition Center. And also we welcome you to visit our Innovex, which is highlights 388 startups from 21 countries. They will be in the TWTC Hall 3, just next to 101. They will start from tomorrow, 6th of June until the 8th. So only 3 days. Thank you again for all the speakers for your great contribution. And thank you all the audience for your participation. Thank you very much.
Thank you, Walter. We would like to invite Walter, please stay on stage for group photo shooting. Ladies and gentlemen, we would now like to invite all the keynote speakers in the afternoon to please go on stage for group photo shooting. May we invite Deepu Tala, Vice President and General Manager of the Autonomous Machines at NVIDIA. Let us give our speakers a warm round of applause as we welcome them on stage. And please help us welcome Rene Haas, President of the IP Product Group ARM, Dr. Ellen Yang, CTO of ADVANTECH. And also, please help me welcome Dr. Winston Xu from the Communication and Multimedia Lab of the National Taiwan University. Once again, let us have another warm round of applause for our speakers. Thank you all for joining us. And gentlemen, please put your thumbs up, all the dear speakers. Walter and all our speakers, please put your thumbs up for members of the press to take a few more photos. Once again, we would like to thank our speakers from NVIDIA, ARM, ADVANTECH, the National Taiwan University. Thank you. Thank you. You may now return to your seat. And we would like to thank Mr. Walter Ye and all the distinguished speakers for joining us this afternoon. And now, ladies and gentlemen, now is the moment we've all been looking forward to, the keynote sessions. The first keynote speaker in the afternoon will be Deepu Tala. Deepu is Vice President and General Manager of Autonomous Machines at NVIDIA. He is responsible for deploying AI technology in devices such as factory robots, commercial drones, and video analytics. Before taking this role, he was responsible for NVIDIA's mobile business unit. Today, he will talk about AI now for every industry. So without further ado, ladies and gentlemen, please help us welcome Deepu Tala.
Thank you for the introduction. Good afternoon, everyone. So AI is such a hot topic in the last few years. We are seeing every industry being transformed by artificial intelligence, especially in the form of deep learning. I was actually looking at, as I was preparing for this, when I was invited to this talk, I was thinking about, okay, what makes AI so demanding? And it turns out that, we found this chart, this was published recently by OpenAI. And here, this chart shows us supposed to come in the middle, or that's? I'm just trying to get. Is it supposed to? Is this right? Are they supposed to come on the sides or in the middle? This is right? Okay. All right. Okay. Okay. So I stay in the middle. Okay. All right. So you can see just in 5 years, the AlexNet in 2012 was essentially what you would say is started the big bang of deep learning, when a artificial intelligence deep learning trained neural network beat all computer vision techniques for image recognition. So that's, you can see at the 2012, you can see AlexNet. And then you see where we are today. And in terms of the number of computing flops that are used every day in the world, in the second, for training neural networks, it has risen 300,000 times. That's how much computing is being done now. So that just shows you how fast AI is being applied to every industry. Now, for the last 35 years, CPU computing, essentially in the form of Moore's law, has driven the computing industry. Every 2 years, every 1.5 years, we would double the performance, and that trend continued for 35 years. And we all know that in the last 5 to 7 years, that wave of computing has come to a halt, essentially. What used to be a 50% growth every year in computing has come to less than 10%. Around the same time as this big bang of deep learning happened in the form of availability of a lot of data from the mobile cloud revolution, GPU computing has started to pick up the slack. And because now GPUs are parallel processors and they are accelerating all these AI and machine learning and deep learning workloads, we are able to continue that trend and move the future. So recently, the latest generation Volta core, we announced it approximately a year ago, it is Volta. And what we did there is, Volta is the first GPU that was designed not only for high-performance computing, supercomputing, but also for artificial intelligence. And how did we do that? We've added a special class of instruction called tensor cores that will help in the acceleration of machine learning workloads. And as a result, we have a GPU architecture that is not only great for high-performance computing, but also for AI. And as a result, Volta GPU is the most powerful GPU, most powerful computing chip that's ever been built. And just last week, we had our annual GPU technology conference here in Taipei. More than 2,000 developers from Taiwan joined us. And we announced 5 speed records based on this for artificial intelligence. The first V100, Volta V100, is the world's fastest chip, single chip ever built. So that is for training. We also have built a supercomputer based on Volta V100 called the DGX-2. And that is the fastest single node that has ever been built. Even fastest at scale. This means you can put multiple of these computers in a data center at scale in the cloud. And Volta has achieved the fastest training performance of ever for training neural networks. So the first 3 things are about training neural networks, which is the first part. Once you train the neural network, you have to deploy the neural network, either in the cloud or either in an autonomous machine or either at the edge in an IoT device. That's called inference. And even there, Volta V100, fastest inference in 1.1 millisecond. An image is sent up to the cloud, ResNet 50, immediate recognition in 1.1 milliseconds. That's super fast. And then in terms of, if you're servicing the cloud inference, throughput matters. Latency matters, of course, and throughput matters. How many inferences can you do every second? Because as mobile users, we are constantly uploading pictures or videos or speech or text or many things that need to be inferred in the cloud. So for all of those, the GPU, because of adding tensor cores, it has not only become a great AI processor, but it's always been a great high-performance supercomputing processor. So net-net, if you think about Moore's law, which is approximately doubling performance every year and a half to two, here, what we have shown is from end of 2012, when AlexNet won the image recognition challenge. At that time, AlexNet was executed on two GeForce GTX GPUs, 580. And then fast forward to earlier this year with our DGX2 based on Volta V100, we have increased the performance of computing 500 times. That's not Moore's law, right? That's not one exponential. That's two exponentials, an exponential on top of another exponential. So how did we do that? We did it because we are optimizing across the entire stack. And what do we mean by the entire stack? First of all, we start with the fundamental architecture. So that's the GPU architecture. That's the hardware. So we've added tensor cores. We've added other features to improve the performance of hardware. That alone is not enough. From there on, we work on the next level of software, which is our CUDA libraries, cuDNN, TensorRT, which are all the AI machine learning libraries that we accelerate using our GPU. And then on top of that, we're accelerating all the different high-performance computing stack. So starts with hardware, the GPU, on top of it, the software, and then the libraries, APIs, and even then on top of that, applications as this deem fit. So entire stack to stack, we are constantly moving it from one generation to the next generation. And that is the new wave of computing. The old days of Moore's law, transistors increasing, you get faster CPUs, lower power, and software can get bigger and bigger, and you can get the performance is over. You have to now optimize across the entire stack. And this is the new wave of computing called GPU computing. So the question that we usually get is, we understand that training is extremely intensive, and I've showed you that in the first chart, right? The amount of computing flops that are being used for training these neural networks now has increased 300,000 times. So it's very clear that you need a high-performance processor for doing training of neural networks. And GPUs are approximately used 100% of the time today. Now, what about inference? As I said earlier, inference is the second step in the process, which is after you train the network, you have to deploy the network. You have to run the network, and that's inference. Is an inference very easy? That's the question that we get. Is an inference very easy to do? And actually, it turns out it is not that easy. When you look at, especially in terms of a data center and an autonomous machine context, it's not easy because look at the explosion of networks just in the last 5 years. It started with traditional convolution neural networks in 2012, AlexNet, which was 7 layers deep, or 8 layers deep. And then you look at the latest image classification networks, they are over 150 layers deep. Those are CNNs. But beyond that, for speech and for natural language processing, neural machine translation, and then you got these video sequences that need to be processed across multiple frames. You have new networks that are constantly coming. Recurrent networks, GANs, reinforcement learning for the next generation of robots, where you teach robots by example. So as you have this incredible number of networks that are coming every day and being invented, and if you are building a product for the cloud or data center or an autonomous machine, you're running different workloads all the time. 1 minute you might be running image processing. The next second you might be doing inference on video workload or on a speech workload or a recommendation engine. or if you think about a self-driving car or a future robot, these are constantly going to be updated in the field for a period of 10 years. So as a result, you need the programmability and flexibility. So GPUs, as it turns out, are great not only at training, but also for inference. And this is a term, as I explained, how complex inference is, especially in the context of a data center and autonomous machine. Plaster. You need programmability, latency matters, and we showed you the speed record earlier. Accuracy matters. Actually, this is an important thing. You think once you train a neural network and once you deploy it on the device for inference, not all inference is the same. Because typically what's happening is when you're doing inference, you convert that neural network into 16-bit or 32-bit or 8-bit, depending on how much computing power you have on your device. And as a result, you will suffer an accuracy loss if you're not careful with it. So accuracy really matters. And so as a result, it's important to make sure that whatever your end data width is versus what you're training the network are matched up properly. Size of the neural network matters because as networks get bigger and bigger, you need to optimize it to the target device, and there's not going to be infinite amount of memory available on your target device. Throughput, of course, matters. Energy efficiency matters, as you all know, and the rate of learning matters. It's constantly changing. So inference, as it turns out, in the context of a data center and an autonomous machine, is a complicated computing problem. And to do that, we have created a compiler called TensorRT. And TensorRT has been adopted by many companies all over the world. And we started back 2 years ago, started with the first version of TensorRT, focused on image video workloads. Since then, we have added functionality for other workloads, such as NLP, in that case, recurrent neural networks, recommender engines. Most of the time, if you are on Facebook or if you're on Twitter or ads, they're recommending you products all the time, and that recommendation networks are also accelerated. Speech synthesis and automated speech recognition. So all of these with TensorRT 4 that was announced recently. TensorRT 4 is now available. Along with that TensorFlow integration, we have seen significant improvement in performance. So this tool is so powerful that if you did not use TensorRT, even the same GPU would run 10 times or 20 times or 30 times slower without TensorRT. So that tool chain is extremely important. And you can see some of the results that we are able to achieve by using this complete end-to-end optimizing compiler. Approximately 200 times speed up on image video workloads, and across the board 50x on average with respect to the other workloads. So how do you take all these tools and essentially deploy in an at-scale infrastructure? That's the first step. So we showed you great GPU architecture that has been, we added Tensor Core. We showed you all the different tools that we provided. And now, how do you put that all in the cloud and everybody can use it? So we built a complete software stack for inference, and Kubernetes is also supported so that you can deploy it at scale. And as I mentioned earlier, TensorRT and the GPU computing platform for inference has been adopted across the world in many different industries, as you can see there, from cloud service providers to recommendation computer and internet companies to recommender companies like SAP. You see mobile companies in the list, and also you see some video analytics companies as well. And just last week, we showed that Taiwan here is essential. Taiwan approximately provides 90% of the world's servers infrastructure. 90% of the servers in the world are built in Taiwan. And our computing platform, GPU-based computing platform, has been adopted across all the partners here in Taiwan, from servers for training, servers for inference, and also servers for supercomputing across all sorts of form factors, from 1U, 2U, 4U, all the way to 8U. So the first thing I talked about today was all about AI infrastructure, the tools that are necessary to develop AI, from training to inference in the cloud. Now I'm going to talk about some example industries where AI is transforming them. And I'm actually glad that I started off first because I got great speakers following me, Renee and my friend Renee and others, that they're going to talk so much more about the applications that my job has incredibly become easier now. Okay, so I'm going to talk about 4 industries here. But as you know, every industry is being transformed by AI. If you think about AI for a second, what's fundamentally different about AI compared to previous techniques? In simple human terms, I think the simple way I think about it is, in the past, engineers used to write software. And software basically was the one that created all the magic that we've created in the last 20 years. Whether it's mobile computing, whether it's supercomputing, whether it is cloud computing, high-performance computing, software was what essentially was the brains, and engineers wrote software. Now, the thing about AI that's different is AI is software that's writing software. So AI is automating that process of software. So another way to think about it is, if you wanted to write great software before, you needed to have a lot of engineers. If you had the best engineers and the most of the engineers, you wrote the best software. Now, if you want to build the best AI, because AI is software writing software, you need to buy a lot of GPUs. Okay, so let's start with, I'm going to talk about 4 industries: automotive, self-driving cars, and then going to touch up upon smart cities, where you can use video because cameras are capturing videos 24/7, and there's not enough humans that want to watch that video and make any sense out of it. So a lot of that video is wasted today, just goes into a disk, and if something bad happens, humans will look at it after the fact. Whereas with AI, we can analyze that video in real time and improve traffic or find a lost person and so on. Healthcare, AI is going to disrupt, transform healthcare as well. And then last but not the least, how do we see AI in IoT devices and consumer devices? Okay, so let's talk about self-driving cars. First of all, it's a huge market. So why are we focused on the transportation industry? Well, it turns out that the benefit to humanity is incredible. If you think about the number of accidents that happen in the world today, how many lives are lost or how much damage is done to property, if we can significantly reduce that, the benefit to humanity is going to be huge. Not only that, of course, if you have these autonomous vehicles, then a lot of old people or young people now who are incapable of driving, now have a way access transportation. And if you have autonomous vehicles, we don't need that many parking spots all over the world which are sitting idle. We can use those better. City traffic will get better. So it's clear the benefit of autonomous vehicles. So we've, at NVIDIA, built this platform called NVIDIA Drive. We started on this self-driving car journey 7 years ago. And we are working entirely across the stack from top to bottom. And I'm going to show you some examples of how we are doing that. And we have over 370 partners worldwide on the Drive platform. And you might be wondering, how is it possible that there are 370 plus partners in the automotive industry? I only know 10 car companies or 15 car companies. I mean, that's probably what you're thinking. Actually, if you think about the whole ecosystem, of course, there are car companies. There's also tier ones. There's trucking companies. There are a lot of startups now that are doing things like solving perception problems, or building a full self-driving car software stack, or doing mapping, or working on different sensors, better cameras, better LiDAR, better radar. All of this ecosystem is working towards this autonomous vehicle self-driving industry, car industry. And we have over 370 partners working on the GPU, NVIDIA GPU platform called NVIDIA Drive. And this is an end-to-end platform. You hear the word end-to-end quite a lot in many presentations. The question then is, what is the left end and what's the right end? And it turns out that the first thing that you would think, or I would think actually, when somebody says a self-driving car, you would think about the car itself, right? What's the computing capability inside the car? Because at the end of the day, the car is the one that's doing is driving itself. But actually, it turns out before you even get to that self-driving car, there are many steps that you need to do before you get to that self-driving car. So at the top, the first thing that you need to do is you need to collect and process the data. right? You see, all over the world, you see these cars with cameras, and whether it's Google cars that are popular, or even you might even see some cars from all the manufacturers that are collecting data constantly. And that is a lot of data that's being collected. There are several thousands of these cars that are all over the world collecting data 24/7, or with humans collecting it. Many sensors. If you think about it, in the past, our current cars typically have 1 or 2 cameras. Those are for ADAS, a front camera and a rear camera. But in the future, these autonomous cars will have multiple cameras, anywhere from 6 to 12 cameras. You have cameras in the front with different focal length. You have cameras on the sides. You have cameras on the side mirrors. You'll have cameras at the rear. And you'll also have cameras inside the car. And the resolution of all of these sensors is going to increase significantly. They're moving from 720p to 1080p. Eventually, it'll go to 4K at 60 frames per second, in some cases even higher than that. And not only cameras, but you have other sensors, such as LiDAR and radar, ultrasonic, and even IR in some cases inside the car. So you have a lot of these sensors that's collecting data. And if you think data collection is hard, imagine labeling that data is incredibly hard. Because you need to basically label, in order to train a neural network, you first have to teach the neural network what's a car, what's a lamppost, what's a license plate, what does a Ferrari look like versus a Mazda, and so on and so forth. You have to do all this labeling. And that takes a lot of computing. Once you did that, you have to train the models. And you've seen the first slide that I showed you, 300,000 times more trainings being done now than before. And one of the reasons is self-driving cars. If you collect all the miles that are driven by humans in the world, there's 10 trillion miles that are being driven every year, 10 trillion miles. There's not going to be enough self-driving cars that will collect that much data. So in order to train all these models, and there's multiple networks that are running, multiple sensors that are coming, you need a supercomputer. And you need to be doing this continuously. So you need a training infrastructure for all these models. The third step is simulation. As I mentioned, 10 trillion miles, human real driving. You have these self-driving cars that are probably collecting, imagine a self-driving car. It's probably collecting 20,000 miles, 30,000 miles, maybe 50,000 miles every year. And you multiply that by thousands. It is not even 1% of the driving that humans all in the world combined do. So how is it possible that you can just rely on driving these cars on the street and learning from it? You actually have to go into the simulation world. So we have created this simulation platform as well, which is 100 times more data. The problem with a self-driving car is not to get to 99% accuracy. 99% of the time, even humans drive fine, no problem. It is the 1% of the time where the corner cases is where we run into trouble. And that's what we're trying to do. And it is probably not possible if you're collecting data in a car as you're mapping it and you're collecting. You probably won't see most of the corner cases. So the answer to get all those corner cases is in simulation. So we've created this supercomputing simulation platform as well. And then you do all of these things. So you got the processing data, you do the training, you do the simulation, all done on supercomputers all the time, and then you deploy it into the car. So that's the last part. So all of this is the NVIDIA Drive end-to-end platform. So we're not just doing the computing platform in the car, all the way from data collection to training to simulation to inputting into the car. So we have a video. This is actually a video of the NVIDIA Drive computer in operation. This is done by our engineers, the complete stack. So I want to show, run it. So you can see the number of neural networks as the car is driving. There are tens of cameras, multiple cameras, LiDAR, radar, many networks, neural networks are running for perception. And once you perceive, you got to reason. And that's localizing. Where are you? What's around you? And then once you figure that out, you're going to plan the path. So all of those running end-to-end on an NVIDIA Drive platform. What do you guys think of that? Melody. Okay. So similar to self-driving car, video analytics is also a huge industry. Because cameras are everywhere. Cameras are in airports. Cameras are in museums. Cameras are in buildings like this. Cameras are at traffic intersection. How can we improve the quality of life? How do we, know what's happening if you want to find a lost child in an amusement park, for example, or if you want to better do traffic signal analysis. Actually, there's been a couple of big city examples that have been done in the last 6 months that have proven that by using AI, you can coordinate the lights better based on how the traffic is flowing across the city and significantly improve the traffic jam. So to do that, what we've done is we've, again, created a complete stack. So you have seen the drive, the NVIDIA Drive. It is a complete stack from top to bottom, from the GPUs underneath to the software libraries to the vertical software stack. In the case of video analytics, we have a platform called the NVIDIA Metropolis. This is for intelligent video analytics. And we have created a SDK called DeepStream. DeepStream is the SDK which is available publicly. You can go to nvidia.com and download DeepStream. It allows you as a developer to feed in tens or hundreds of cameras into one time, into this software component. And all those channels are processed together. So that's what DeepStream allows you to do. Because if you think about it, if you have a camera around this building, one camera can only see this much. So you have the next camera, you have the next camera. It is important to know not only what this camera knows, but what's happening in the next camera in space, but also in time. What happened 3 minutes ago is important. If you want to predict the direction of traffic, you need to know what happened in the last 2 minutes to know what's happening next. So to do all of that, you need to ingest massive amounts of data and process all those together. And that's what DeepStream allows us to do. So you can do things like anomaly detection. You can do heat maps. How is the foot traffic in a concert, for example, traffic detection, and so on and so forth. And the NVIDIA Metropolis platform has been adopted by over 100 partners worldwide across different smart city and safe city markets. Healthcare is a huge opportunity. AI is going to transform it. And I think we have a speaker from Google. I'm sure he will explain a lot more than I will here, but I just want to give you how AI, NVIDIA Clara platform is going to impact healthcare. You have all these medical devices that are already existing today. It is not practical to replace all of them any time. So the answer is you want to bring AI to those machines. So essentially, you send all the data into the cloud, and then you can do medical imaging on that data. First thing you can do is using artificial intelligence, you can do reconstruction. Improve the quality of the image that's coming from an MRI or an X-ray much better with deep learning than the traditional machines. And once you do the reconstruction, you can do imaging, and then you can do visualization. So doctors across the world can predict diseases faster, can get higher quality images to do medical imaging. So I talked to you about the cars and smart cities and healthcare, but this is other big market, and I'm sure Rene will talk about it quite a bit. 1 trillion intelligent devices soon. IoT, AI is going to be everywhere, right? Every semiconductor, every electronic device in the future will have AI inferencing. I think that's not a surprising statement. Whether it's in cities, factories, agriculture, automotive, or personal devices. Now, I showed you about all these world's latest, greatest GPUs. Do you really need a GPU for doing some of these things? And the answer is no. You don't need a powerful GPU in a rice cooker, for example. You don't need a Volta V100 into a small camera, but you still need to do deep learning. What is the answer? The answer is a deep learning accelerator. So we have built a deep learning accelerator called the NVDLA. And in fact, that deep learning accelerator has been in our NVIDIA Drive Xavier SoC. And we do deep learning not only in our self-driving car with our GPU, but also with deep learning accelerator. The reason we do is we want to have diversity and redundancy in a self-driving car. For safety reasons, you want to do it differently. So we have been developing a deep learning accelerator for many years. And we developed it. We actually taped out a chip, and it's already in production. So what we've decided to do is, because NVIDIA, we directly do not make IoT solutions, we have open source NVDLA. So if you are an IoT chip company, or if you are developing a deep learning accelerator, you should take a look at NVDLA. It's free. You can take it. You can modify it without any royalties. It's already. And recently, we have announced a partnership with ARM, where ARM has taken the NVDLA and made it part of their Trillium machine learning platform. I'm sure Rene will touch upon that. OK, so with that, I'd like to summarize. So NVIDIA is the world-leading AI platform, all the way from desktop to cloud, to a desk station, to a self-driving car, to an autonomous machine, NVIDIA Jetson. Same architecture, same software that goes all the way from the cloud to the edge. With that, I'd like to thank you for your time.
Thank you very much for joining us this afternoon. And ladies and gentlemen, today's second keynote speaker will be Rene Haas. Rene is president of ARM's Intellectual Property Group, IPG, and a member of the ARM Executive Committee. He took over management of IPG in 2017 and is responsible for all IPG activities, including product development, engineering, sales, marketing, and commercial operations. Today, he will talk about humanizing AI. Please welcome Rene Haas.
Ni hao, Woshu Rene Haas. Thank you for having ARM and myself at COMPUTEX. Thank you, Deepu, for a great talk and introduction. Put a little pressure on me to make sure I cover some of the key points. When I think about, Deepu was talking a little bit about artificial intelligence and the fact that in the past, humans used to write software, and in the future, computers will write software. I really wish that existed when I was in college. That would have been very, very nice to have help to get my coursework done. So I have been at COMPUTEX many years. I was thinking back, this is probably my, 11th or 12th, COMPUTEX. I first came here in a different life, and we were talking about laptop computers and the fact that laptops were going to slowly take over desktops, and there would be a transformation in terms of how people worked and lived and played. And fast forward 10 plus years, and we're talking about self-driving cars and artificial intelligence and everything that's going on with that. And it's all very real. As Deepu had shown through his presentation, this is not science fiction. This is not Star Trek. This is very, very real, and we are on the cusp, I believe, of some very, very significant technology advancements over the next few years. So Deepu and I did not work on the slides together, but the numbers are consistent in terms of how we think about where the growth is. So this number of 1 trillion devices and where the market's going and all these devices being connected, a lot of folks ask a bit about, is this a far-fetched number, or can we really get to that kind of number? It seems extremely large. Just to put it in context a little bit, if you look at the numbers here, about 3 billion smartphones and 8 billion connected devices, just to put it in the context of our company and the partners that we work with. So ARM started in 1993, so about 25-ish years ago. And in the first 20 years of ARM's existence, between our silicon partners, our partners and their affiliated devices shipped about 50 billion devices total. So first 20 years, 1993 to about 2013, total is about 50 billion. The next 5 years, 2013 to 2017, was another 50 billion. So just on the ARM partnership alone, it took 4 years to achieve what the partnership did in the first 20. And that was 20, and we talked about that statistic last year, 50 billion in the first 20 years, 50 billion in the next 4. In the last year, 2017 ending in 2018, the partnership shipped about 20 billion devices. And if you just think about the growth rate going forward, getting to 1 trillion connected devices is not very far-fetched. And I think one of the things that has changed a little bit, though, when we think about connected devices and what that means relative to intelligence in the network, a number of years ago, we thought about these devices would be connected to the network, they would have a sensor, they would have a connectivity device, and they would latch onto the network. But what's rapidly changing is that these devices are getting smarter. These devices are intelligent. Some of the things that Deepu talked about in terms of inference and learning and the things that take place. Not only are these endpoints going to be significant in volume, but they're going to be very significant in terms of the numbers. So when we think about it just in terms of raw compute, and this is just a rough estimate of when you think about the compute power that exists in all the devices that are in aggregate today, you can see it's a fairly large number in terms of gigaflops. But going forward, this number is going to explode. And it's going to explode for a number of reasons relative to the compute power that will be available in these end devices. 5G is going to enable all type of different applications, endpoints, compute power, whether it's at the cloud, whether it's at the base station, whether it's at the end node. And then simply the fact that all these applications that will run and drive these use cases will draw a significant amount of compute power. So what does that mean? Well, we're looking at a very significant cusp of an age relative to data and AI. And the ramifications of this are going to be very, very significant. It's not just going to be about how fast your web pages load or how quickly you can connect to the network. Areas such as health, as smart city, smart home, driving, things that are very, very significant from a social standpoint, and this is very, very significant. AI is going to impact not only the way we work and play, but the social impacts of how society operates. So the implications and how the companies and partnerships and countries work around AI is going to be really very important. And with that, comes risk. So, there are a lot of concerns about artificial intelligence and what it means. And you can look at some of the numbers here. Deepu did a great job talking about all the things going on with autonomous vehicles. But the issues around security, the issues around making sure that those devices can be secure, the networks are secure, the information in the automobile, you can see the numbers here. There's also a huge amount of concern just relative to the data, right? Our own personal data being stolen, hacked, moved in a different direction. The numbers here are very, very large. And this is a very significant one. Going back to the artificial intelligence and software writing software, what happens when the machines are actually smarter than humans? And what are the implications of that? And then, of course, with that, sort of the whole notion that there could be bad actors using these devices for all kinds of different ways. So, with all of this type of technology and all this type of innovation, there are very, very significant social consequences of which impacts everybody, inside this room, all the companies, all the governments, the countries that work through this, very significant. So, for us, though, we think that there's some very, very interesting implications just today of what defines our relationship with AI, right? So AI is in our lives today. There are things that we do that 5 years ago we would never think of doing. For example, getting in a stranger's car, sleeping in a stranger's home, swiping left. Well, that's Uber, that's Airbnb, and that's Tinder, right? That's what millennials do, right? I can't imagine, we talked today about children who go on play dates and they're all organized and such, and we would say, oh gosh, when I was a little kid, I would just go to my friend's house and play. I wouldn't tell my parents. On the flip side, Would I ever get in a stranger's car that I just said he'll be here in 2 minutes? Wouldn't even think of that. But that's AI. And probably as importantly, it's also a technology that was enabled by a confluence of technology and platforms. You know, for example, the idea of using a GPS and logging a destination and where you want it to go, et cetera, which is the concept of Uber, great business plan, but you needed 4G and all the things around GPS and location tracking and artificial intelligence to make that happen. So when you fast forward to 5G, and all the things that 5G will bring in terms of low latency networks, high performance, et cetera, 5G is going to enable a set of applications and a set of areas around AI that we can't even imagine right now. And that's the way these things tend to work in technology. It's not just one single entity that's invented or one single technology. It's the combination of the underlying platform has enough performance, some smart people figure out exactly some application models that can work. You have a social generation that comes in that's much more comfortable with technology. So again, going back to the Uber, Airbnb, you have millennials who are now very, very comfortable with that business model. When we fast forward into this new world, it's going to be very, very significant in terms of what the changes are. And that's going to be a very, very, I think, exciting thing for us. So, you know, when we think about all the different things that kind of come with AI and artificial intelligence, you know, we do a lot of these things today, whether it's unlocking our phone, face recognition, et cetera, things that are, again, in the daily use case of things that we would just do through work and play. But there are now starting to be some very, very significant applications that are a little bit outside the norm, and I want to share one with you now.
I remember that I was 9 and I had asthma and it was painful to breathe. I was scared that it never go away.
It was very painful to see that he cannot do the things a normal boy can do at his age. This is all the medicine Sam is taking and it's not working properly for him. So what does work for Sam? We are not sure.
Sam loves gymnastics and he's really good at it, but it's only possible when he can breathe easily.
I'm afraid that when I tell my friends I have struggles with my breath, then they laugh at me. Sometimes I forget to take my medicines in the morning.
When you don't take one of those 6, it's a hell.
2 years ago, I met this creator of this device that has all this machine learning in it. It's fitted with an ARM-powered chip. It's foundational IP used in up to 70% of all technology that we use on a day-to-day basis. It's going to transform the way we treat asthma. For the first time, we have a machine learning inhaler that connects to Wi-Fi and sends data back to us. We can notice that they're not inhaling as strongly as they should. We can give feedback to them, so they will actually benefit more from the medication.
Knowing that a patient and a doctor are connected to each other and you get a message about how to adjust your asthma treatment,
it's much easier for us to handle the asthma.
what we really like for Sam is that he can do everything he likes without his asthma. This isn't only about Sam, this is about the future of asthma treatment for children everywhere. I am Danielle, and our future is made possible by ARM.
So this is a really cool example, right? I mean, when you think about machine learning, connectivity, smart devices, what is an example of a real benefit? You know, this is a real living, breathing example of something that's fairly significant. And the healthcare industry is frankly one that is in need of a transformation like this, right? So if you think about this small example, right, of a very simple device, an inhaler. This inhaler is equipped with a small component that has a ARM-based microcontroller. It has a small algorithm to do the machine learning that will basically learn based upon the inhaling that's been done or not done, and then through a connectivity piece feeds the information back. Rather simple, right? Well, one of the biggest issues in healthcare, particularly with prescriptions, is the system is completely open loop. When a doctor prescribes medicine to a patient, write it down on a slip, they go to the drugstore or the pharmacy or wherever it is and takes their medicine, and if the doctor doesn't hear back, I guess it worked. But do they know that the patient actually took the medicine? Not exactly. Does the drug company that's been doing the testing know that the medicine has been taken and has been doing what it was designed to? Not really. So when you think about just a system like this in terms of the profound impact it can have on the industry, in terms of better healthcare, better diagnostics, then also in terms of the pharmaceutical industry, in terms of getting better information about their drugs, better information about what can be done, better information about future products, it's very, very significant. Not to mention the huge benefit to the patient, right? The patient is now in a much better situation to be diagnosed in terms of the proper medicine, the proper dosages, everything around healthcare. So this is a really small example, but I think a really interesting one relative to what we're starting to see around ML and machine learning. And with that is coming, a lot more of this intelligence at what we call the edge. A lot of questions I get from time to time is, well, what is the edge? Are you at the end of a cliff? What exactly does it mean when you talk about edge computing? Simply put, it means the devices that are most likely physically on your body or on your endpoint. So that can be an inhaler, that can be a mobile phone, that can be your Alexa device in your home, it could be Google Assistant, it can be anything, but, and this I think was also reinforced by Deepu's presentation, more and more machine learning is taking place closer to the use case. And again, when 5G begins to take off, 5G is going to enable a whole new set of machine learning and inference at the edge, because these new networks will have a much lower latency, will be able to process and handle data much more quickly, and with all the aggregation of data that comes with 5G, you're not going to want to take big hops to the cloud to do your training. You'll want to do that in interim steps. So 5G is going to be really significant in terms of what that impacts. And with that, there's just going to be all kinds of different applications, whether it's going to be around smart homes, smart learning, that'll be very, very significant for the growth rate of ML. So, where are we seeing it today? Well, smartphones, for example. It's actually, believe it or not, the world's most popular AI device. Showed the numbers earlier, about 3 billion smartphones being shipped. Believe it or not, about 1 billion of those, 1B, have some level of machine learning already designed into these devices. And these are things like fingerprint recognition or face recognition or other things that make the device simply more intelligent. We're starting to see already a lot of mobile manufacturers integrating machine learning into the end devices, and this is only going to continue. Whether it's digital assistants, predictive text, you're starting to see this a lot even today if you use some of the popular mail applications that will suggest all type of things that can be done. That's a combination of machine learning on the device and on the cloud. So it's happening in a pretty quick way. And the use cases are, they're just not phones. And, Deepu talked about some of these as well, whether it's autonomous driving, whether it's intelligent drones, whether it's all types of different type of end products that can enable machine learning. You can see a few examples here. It's a pretty broad swath. And we're really, really just at the very beginning. And it's happened fast. I know, again, 2 or 3 COMPUTEXes ago, we weren't talking about this at this scale, at this level. And for the next number of COMPUTEXes that I can imagine, this, I'm sure, is something we're going to spend a lot of time talking about. It's really going to be a significant change. Now, why is ML moving towards the edge? I talked about a few of these already. I talked about the number of the data hops, et cetera, et cetera. Cost is a big issue, right? That's a very large issue in terms of distributing costs throughout the network. Security is a big issue. You want to be able to secure your data closest to the endpoint. The less times that your data has to leave your device and go through hops to a cloud, the better in terms of security. Power is a big deal. There are a lot of applications that have spaces for power, but there are a lot that don't. One of the examples that were shown in terms of the autonomous driving, Increasingly in these automobiles, the area to put the cameras, the area to put the microprocessors and the controllers are pretty small, and they're very, very constrained in terms of heat and space. So with that, you're going to want to have more and more of that machine learning taking place at the edge. And then obviously, bandwidth, as I talked about, whether it's 5G or the amount of data you're pushing down the pipe. So when we think about machine learning, and again, Deepu and I did not work on these together, there is a synergy relative to how we think about the product space and where the solutions are. So by way of reminder, our business is intellectual property. That is, we license IP to people who make semiconductor chips that go into all kinds of systems. So we offer a broad set of solutions around machine learning. We have CPUs, we have GPUs, and these are devices that are general purpose, but also have extensions relative to machine learning that can accelerate certain algorithms. We have our own product around ML, but we also support third-party accelerators, such as the deep learning accelerator that Deepu talked about. And they all fit inside this platform that we call Project Trillium. And Project Trillium is really about a suite of IP that our semiconductor partners can integrate into an SoC. We provide software frameworks for development, and then partners can program in their favorite language, whether it's TensorFlow, Caffe, etc. One of the questions I get a lot is, what's the killer app for ML? Where is ML going to be used, and where do you see the growth of ML? And my answer to that question is yes. I think 10 years from now, we're not going to talk about ML in the sense of computers learning. 10 years from now, it will be assumed that all computers learn, and all computers are smart, and all computers get better and better over time. So when we think about machine learning, we think it goes all the way from the data center down to object detection, pattern training, even at the keyboard. Every end application will, over time, have some level of AI machine learning. And for us, when we think about the solutions that we provide to our partners, it's a combination of CPUs, GPUs, dedicated accelerators with the libraries, as I mentioned. We talked about a few products this week. If you were around at one of the product launches yesterday, we announced a new CPU and GPU that is targeted for very high performance and also with ML applications. And we also, as I mentioned, have a dedicated platform around machine learning. We have a device that is our own neural network processor. So this is more tuned for the edge. Again, it's low power, low footprint, designed for IoT, smart city, et cetera, et cetera. In addition, one of the first companion products we have with it is an object detection device. And this is for face recognition, pattern recognition. So if you use the two devices in combination, you'll have a very, very unique platform for doing face recognition, for security, et cetera, et cetera. So we've started this in the last couple of years. We've made a lot of progress. It is, again, an area that we have just seen. I think the potential is rather unlimited. And I think for all of us, the implications are really profound relative to everything that we're doing in terms of work, live, and play. So again, just to kind of summarize, I think when I think about my years in the industry, and I've been doing this for a long time, a lot of people stand up and say, this is the most exciting time I can possibly remember in my career. But I actually truly believe that right now, this is a really unbelievable time, because not only are the implications pretty exciting for someone who's a native geek engineer like myself, but when you look at the health video in terms of the asthma device, you can really start to see that this is going to change people's lives. Whether it's self-driving cars that are just going to be safer, whether it's drug companies that can provide better medicine, whether it's patients that can now be healthier, the implications for us are really significant. Doesn't come without threats. I talked about earlier all the things relative to security, bad actors, hacking of data, et cetera. It's going to put a level of responsibility on the industry we have not seen before, right? So we had a a bit of maybe delta or alpha experience, if you will, with the Spectre and Meltdown crises of the earlier in the year, and that required the entire electronics ecosystem to work together. I think going forward in this area of AI, that's going to be a significant challenge for all of us to work together. So with that, thank you very much, and hope you have a great rest of the week.
And thank you so much, Renee, for joining us this afternoon. Next speaker will be Dr. Ellen Yang, Chief Technology Officer of ADVANTECH. Ellen joined ADVANTECH in 2014 and has been leading the company's corporate CTO office, responsible for Innovation Management Center, Corporate Engineering Services, Corporate Software Services, Integrated Product Development, Management Process Framework, and Industrial Design Team. And today he will talk about when AI crosses industrial IoT. So without further ado, let us welcome Dr. Ellen Yang.
Good afternoon. Well, it has been a great afternoon. I've heard great speeches from the speakers from NVIDIA, from ARM, and from Google. And as we all now come to appreciate the great potential of artificial intelligence, there's this huge excitement of what will AI brings for all of us, right? The big technology giants have proved that AI has this huge potential to bring benefits across many segments. At ADVANTECH, we specialize in dealing with industrial scenarios. And by industrial scenarios, probably most of us who regularly attend COMPUTEX is familiar. By industrial scenario refers to anything related to non-consumers, non-home use, non-office use, and everything else belongs to the so-called industrial segment. For example, like in manufacturing, like in transportation, like in energy, in environment, in machineries, and the list goes on. All right, so when we first noticed that the success of deep learning models in the consumer internet, we started to appreciate that the huge potential may be applicable in industrial scenarios as well. So today I would like to share how we, in the industrial segment, look at how AI can be adapted to improve the efficiency of many of different vertical segments. First of all, I'd like to roughly reflect upon the history of the so-called technology industry in the past 30+ years, pretty much along with the history of COMPUTEX or with Taiwan's IT industry. Around year 1985, Intel and Microsoft jointly created the so-called PC industry. I think Taiwan has tagged along and has been very successful in participating in this so-called Intel platform. We routinely manufacture roughly 200 million units of PCs, and transitioning from desktop to notebooks, and then adding on the internet connectivity around year 2000. So that was a golden 15 years for Taiwan's so-called IT industry. Great prosperity, good growth every year, created lots of fortune for many people who participate in these shows in the many years in the past. Then roughly at year 2000, we had this so-called the internet bubble, right? So bubble entailed that there was this huge expectation, very high hope that internet connectivity might bring something wonderful around year 2000. So every IPOs with the name something.com got multiples of appreciation on the date of their IPOs. And then as time went by, we all started to learn what's truly valuable and what's just a phase, right? So in the next 15 years, from year 2000 to year 2015, we come to learn that the so-called internet-based economy really has brought in huge values. But then the value really lies within the services based on internet, based on connectivity. So lots of new valuable technology giants emerge. Amazon, Facebook, Google, they all came along in the last less than 18 years. So that's the second wave of the so-called technology evolution. It's built on top of the connectivity. Now comes the third wave, which is built on top of still is the connectivity, but now evolved from the human connectivity to the so-called the connectivity of everything. And the driving force for the third wave will be moving from smartphone to IoT. Used to be based on connecting all the human beings to address our social needs, to address our search need, to address our hotel room reservation, to address our ordering takeouts. Move away from or extend beyond connecting human beings to connecting a lot of different assets of interest. And then from there, there's lots of data that is coming in that has potential huge value to be extracted upon. And in the past 15 years, it has actually proved by deploying machine learning, deep learning, especially deep learning methods, is the best way, the most effective way to extract value out of this huge volume of data. And then it's the AI. Now, I think all the three speakers has also mentioned they have contributed a lot of open sources. In the past 20 years, we have also noticed that the huge fundamental shift in the software landscape, right? Lots of enterprise-grade, production-grade software packages actually has emerged and been adopted and was field proven to be of truly reliable. So the open source movement also has opened up the door for any startup company, for mid-scale company without a lot of investment of software engineers to participate in this new era of business opportunities. And then because of the huge computational demand, new technology evolved from the so-called clustering computer, from the massively computational data center, and there is the cloud platform. And then to be successful in the business, the new approach of engaging your software solution with the market is actually through fast iteration of trying out, right? Deploy your solution and see how it interacts with your targeted audience and fast iterate. So that's the new norm of success company in the third wave. And then if we examine the net result of how the past 15, 18 years has crushed the technology segment, we just look at the top 10 global company in terms of the market cap. Right now in year 2018, if you read through the list, Apple, Google, Microsoft, Amazon, Facebook, we see these are all technology companies. If we contrast them against 10 years ago, where we see oil company, telecom company, and bank company, it's a big shift in the landscape. What introduced this big change is actually the business model driven by the so-called the platform technology that really has caused this big sea change. So we have to incorporate both the technology factor and the business model together to appreciate how fundamental that the so-called the platform revolution has changed the landscape of many industrial segments. And it had fundamentally changed many consumer sectors already. And it's going to change, again, fundamentally, many industrial segments as well. So based on industrial research from McKinsey, it was already roughly 3 years ago, that the prospects of the economic value of IoT when it becomes mature, the top segments will be in industrial segments, in the so-called smart factories, then smart cities, and then the number 3 is then the consumer scenarios, which is the so-called personal wearables. Depending on which country you are talking about, manufacturing industries roughly accounts for 30% of GDPs of most of the country, plus minus 5%. All right, so manufacturing is actually a huge part of our economic activities. It has gone through several big wave of productivity gains, but then with IoT and AI, we actually see very real opportunity that it will have another wave of huge productivity gain as well. That's what we typically heard as so-called Industry 4.0 or China 2025. In the many segments that will be impacted by IoT, it just so happens that ADVANTECH in the past 30 years, because we have been focusing on so-called industrial segments, by selling the so-called computing platform embedded system into these segments, we are very familiar with that. A very brief introduction to what ADVANTECH does. We were founded roughly 33 years ago with about 8,000 employees globally, with revenue of about 1.5 billion USD last year. We have large manufacturing sites in Taiwan still, accounts for roughly 50% of the productivity and another 50% in China. That's us. All right, now comes to AI again. I think we all come to know that for a majority of AI inference engine, it takes data, large amount of data. When we shift our focus into the so-called industrial scenarios, when we try to address industrial scenario problems, it used to be it takes a lot of domain know-how. We require skilled workers to know whether this equipment is functioning optimally, or we take skilled workers to know whether this so-called work in progress, whether it is of good quality. We bring in a lot of automations already. We bring in a lot of equipment to help with the manufacturing process already. And yet, all this so-called the skilled knowledge, the domain knowledge that is required in this process, we found real good opportunity actually to deploy with the AI algorithms and then to come up with vertical AI that we already have a good experience in improving the productivity in these vertical segments. All right, so when it comes to building up a vertical solution with IoT and with AI, we need to have a complete system perspective from edge to edge, from end to end. So it actually starts from the sensors attached to the point of interest. And often it is probably sensor attached to the manufacturing equipments. Sometimes it is sensor attached to a wind turbine, for example, or attached to the solar panel, or attached to a transportation vehicles, all right? So at the very bottom layer is actually a collection of different type of sensors suited for different vertical scenarios, suited for different industries that probably has to go through different type of industry certification, right? And at the second layer from the bottom is actually called the edge intelligence servers. Speakers from ARM, Renee mentioned about edge computing, edge intelligence. We see the very same architecture plays an important role. The edge intelligence basically sits on top of more or less traditional computing platform. It shoulders the burden of one edge intelligence server taking care of probably tens of sensors, collecting the data from the edge, from the sensors, and do the so-called on-site first line processing response, applying the AI models that has been trained before, right? And that model could be used to simulate the domain knowledge of the skilled technicians. And then going on top to the so-called solution-ready packages. Then it's the so-called vertically specialized application, be it in manufacturing, be it in transportation, be it in energy, be it in retail, all right? It used to be relying upon on the management team, relying upon on the operators to watch on top of the industrial operations of your system. Gradually, that knowledge, that domain knowledge that require operators to diligently watching over the field situation, we could have autonomous system taking care of it or facilitating part of it instead. And sitting on the very top is the management dashboard, the control dashboard that is deployed for that particular scenario. So we have roughly categorized them into, say, smart city solutions, or Industry 4.0 solution, or E&E, energy and environment solutions. And to get all these layers to talk to each other smoothly, you require actually a huge stack of software to pull them together, and that's on the right. We call it WisePath. It's a collection of layers and layers of software stacks. Many actually is adaptation of some form of open source packages. Many of those are actually partnership with our solution partners, say, with ARM or with Intel or with Microsoft. It's a collection of required software stacks that run the sensor at the very edge to the edge intelligence server, kind of sits as a local master that up into the cloud. So if we look into the software stack in more details, basically you have a so-called platform as a service. It's a data-driven design instead of a so-called functional-driven design. A data-driven design has various type of database sitting at the center that is taking in the data from the edge, from the IoT sensors. We have a composition of different variety of databases sitting into this path. We have relational database in the form of Postgre. We have NoSQL database in the form of MongoDB. We have time series database in the form of InfluxDB. We also have deployed in-memory database like Redis as well. So at the center of this platform as a service is actually a collection of highly tuned, highly fine-tuned, well-performing database based on a class of computing services. And also taking a good reference from the computing structure of consumer internet, we have brought in a scalable compute resource management foundation based on Cloud Foundry and Kubernetes. Again, it's a already very popular open source packages that all of you, if you want to try, you can actually download, install, and try it out. It's a proven software stack adopted by many industrial platform companies already, all right? And then toward converting the whole structure into a business, you need to run so-called IAM, Identity and Access Management, that is based on Open Authentication 2, OAuth 2. And once we have all the data in place, now it comes to, I think, the main theme of this forum, which is actually based on this data and also combining with the knowledge of the field participants, which is doing all the data interpretation in the form of labeling, to convert the data into meaning. By combining data and then the analytics coming in the form of various type of neural net models, we are actually able to usefully convert the data into the form of so-called inference engines successfully. At the upper left corner, which is a set of software services actually to visualize the data and the result, the analytics in the form that is more efficiently communicable with your targeted users. All right, so this platform as a service basically is a data-driven design in the core with analytics, with visualization, with a compute resource management framework, and with an identity and security management framework at the middle. When we tie all this together, actually is a pretty good industrial data platform for us to try out different type of AI models to incorporate our technicians or our experienced operators' knowledge. But then we still need a lot of data coming out from the edge. And in industrial scenario, often the industrial edge are legacy equipments with long-standing proprietary protocols. So it just so happened that fortunately, ADVANTECH has been in this segment for a long time. In the past, we were in the field of automation in the various type of factories in various type of fields of energy or environment monitoring in the form of transportation control. So in the past, our embedded system were controlling the equipments. We already had to deal with various type of signals, various type of industrial protocols. So we are just so happened that we know the edge. We know the extremely fragmented scenario in the everyday life of industrial segments. Now it just so happened that we tag it with wireless communication, then we ship it to the cloud to combine it with the so-called platform business model and convert it into a so-called industrial cloud services. Industrial cloud services, the concept kind of similar to Uber or to Airbnb, just that we're not dealing with car, we're not dealing with room, we're dealing with mission critical equipments. Then the idea is then AI training and retraining, and then AI deploy and redeploy on edge, okay? So in summary, to leverage AI models in the industrial scenario, you need all type of algorithms, all the neural nets, and then at the same time, you also need the data sets. Then with that data-driven infrastructure, then you can convert them into possibly useful inference engine to address very type of professional problems. I think speakers ahead of me has raised examples on autonomous driving or medical imaging and on machine learning-based inhalers. And for our use cases, we actually address non-consumer scenarios. So I will raise a few examples as well. So not to dig into too much detail of the AI model training framework that we offer, but it's a compilation of the typical training processes, right? So every lab, every company who deal with the so-called AI model training, they pretty much have to do, the similar steps. When these are put together, you basically start with either you leveraging an existing open source model, or you actually compose a few of them by writing a Python code from the very left. And then there is this IDE based on Node that you can compose a few AI model together, or you can run a few models in parallel if you have enough compute resource to try out. Then you dump in the data set, and then you have your first model, right? Once you have your first model, you can deploy it at the edge, run it online in parallel with your human counterpart to try out if your trained model is accurate enough. For those exceptions, you collect the data again, right? For the model that did not produce the right prediction, collect the data, ship the data to retraining again, and then redeploy. Through this cycle, actually, the model indeed can get better and better. I'll give a couple of examples in our own factories, right? ADVANTECH factory produced roughly $1.5 billion worth of goods last year. One of the steps is actually through the machine temperature through an equipment that is temperature sensitive. It used to be, if we want to make sure this equipment's temperature is strictly adhered to the production requirement, we have to periodically calibrate, take the measurement with a temperature measuring board, flow it through this equipment, take the actual measurement, and believe the operator is disciplined enough to maintain the equipment with that temperature profile for the next batch of production, right? It's basically a belief that the discipline will work, and then we check it afterward with our test equipment and our QA. Well, we feel that we could probably do a lot better than that, so we actually set up a temperature measuring line to take the 13 temperature zones with that sensing lines. But then it's an indirect measurement. How are we sure this indirect measurement would actually correlate correctly with the temperature actually on the surface? So we actually started out trying deep learning models. We calibrate, right, the indirect sensing, the temperature taken from the indirect sensing device versus the actual temperature that we measure from the real surface. And with a few rounds of calibration, the deep learning model trained temperature prediction model actually come within plus minus 2.5 degrees with acceptable temperature accuracy. So the huge benefit is then all the production, the entire batch, we can have a real-time monitoring of the critical temperature production profile attached with every piece. And with that, actually, our customers are much happier because the high demand on reliability of the product we produce for them actually is critically dependent on the temperature profile being correct. A second example is at another stage of the production, we used to rely on skilled operators' visual inspection. We actually have surveyed all the automatic inspection machine in the field up to this point, but none of the automatic inspection equipment is accurate enough. So we decided actually to start trying out deep learning model by collecting images from our own production lines and having our operator to label the defects and what sort of defect with that. The story, sounds a bit like, what Google mentioned with the diabetes-related eye diseases. Again, it's image recognition. All right, so with roughly 8,000 pictures, and roughly after 3 months, we were able to train up a model that is fairly accurate. By about 3 months of effort, the first version of that deep learning trained model, by the way, is based on ResNet of roughly 52 layers of reinforced learning. The first model is already more accurate than our operator, but then it still gets improved as more exception is collected. So to summarize the benefits that we have experienced in our own factory is that by identifying suitable problems within our own production environment, I raised 2 real examples, and actually there are more. We were able to, again, improve the productivity of our own production, of our own factory. And as we speak right now, we actually are engaging a lot, several big manufacturers with revenue above, with revenue above $1 billion US. The top management of all these manufacturing sites, they are interested in employing AI in their own manufacturing site in controlling the various type of key aspects. All right, so I think it's our own personal experience in combining IoT and AI and reaching good result in generating benefits. So by sharing our example, by sharing our experience, we hope to communicate with all of the participants of this forum that AI indeed will have very strong impact across all different fields, not just on driving or on medical imaging, but on our day-to-day experiences. Let me just finish up with very quickly with 2 more segments that we actually have found good use with AIs. One is on retail, right? Intelligent retail. With AI being brought in, we kind of come up with like an intelligent store manager to predict how much inventory needs to be called in, sales prediction, staffing requirement, and auditing. All right, all this actually used to be requiring experienced store managers to do a good job. Now the AI module actually can help with them. Now it's the more traditional application of AI in transportation in picking up all the vehicle-related information, speed, license plate, whether you illegally park on the roadside, all that. Used to be requiring, again, human judgment. Now it's all automated. This platform, I mentioned wise part in collecting industrial data sets. We have 2 types of instances. One is running on public cloud based on Microsoft Azure data center. Another one is based on OpenStack running on private cloud that has been incorporated by several huge manufacturers in China and in Taiwan. Again, we have a full development site available. If you are interested, you can take this QR code and dig in to see how to start with AIoT. All right, thank you for your time.
Thank you, Dr. Yang, for your excellent presentation. And the next speaker will be Dr. Tao Leng, Senior Vice President of Technology at Supermicro. Dr. Tao Leng is responsible for the development of emerging technologies and innovation projects at Supermicro. He has been working in the server and storage industry for more than 25 years. His area of technical expertise resides in high-performance computing and data center solutions. Today, he will talk about architecting the next-generation compute, storage, and networking in accelerating AI/ML. So without further ado, ladies and gentlemen, please help me welcome Dr. Lung.
Thank you. Good afternoon. Welcome to Supermicro section. My name is Tao. I'm the Senior Vice President of Technology at Supermicro. So today, I'd like to talk about our viewpoints of our hardware solution for accelerating the AI and machine learning. Okay. Just for people who doesn't know Supermicro too well, 30-second intro. So we are a 25 years old server solution company. And we started at the Silicon Valley 25 years ago. Now we are a global operation. We have 3 major sites. One is in San Jose, which is where the headquarters is. And we have Netherlands operation and facility center, and also in Taiwan. So we started as a subsystem company. Now we are a total solution company. There are a few fact checks for your reference. IDC ranking us as number 3 server solution provider company in the world, constitute about 5.8% of the market share. Please keep in mind, those are the branded solution we're talking about. For those people who know Supermicro a long time, we also have non-branded or so-called white box solution. So total add together, pretty much about 12% of the market share we have today. Last year, we shipped about 1.2 million units. Interesting to see that about 15% were associated to HPC or accelerated computing or AI application. So that's why it's a very important business for Supermicro, as well as, I believe, for many other companies. Another few facts I'd like to share with you. Is a machine going to take over the world, right? There are a few things I'm going to talk about. For example, over the last few years, we have 14-time increase on the startup company, which is associated to the AI application. And also, you can see 6 times in the past 2 years, the VC money invest on the startup company increased 6 times. So you can see where's the opportunity, where the money will go. The other thing is, oh, by the way, we are in Silicon Valley. So you can see those startup companies here and there pop up almost weekly basis. And just like the bamboo shoot, they pop up every when there's after the raining. Another fact I'd like to show you is that, on the other hand, the research and the academic world, they also produce so many researches for the past years, 9 times compared to about 10 years ago. So you can see everybody working on this because there's a market demand. So the past 2 years on the market, AI job about 5 times growth. Okay. Another point you can see is a robot import, also 3-4 times in the past 2-3 years. So the point is, we are working very hard, right, on the AI area, including us in this room. For what? I think it's for the machine. So ironically speaking, we work for machine, and the hope is that in the future, machine can be better and smarter, so they can work for us. Okay. For today's talk, I'd like to touch bases on a few things. The first thing is about machine learning associated to the IT industry progression. And I'm also going to touch bases on the machine learning, its cycle, its process, and its modeling. Number 2, I'm going to talk about the big data. I believe the previous speaker also mentioned the data is important At least in my view, the big data and training and inference are the three basic phases for the machine learning. Number three, I'm going to show the most powerful training machine in the world today. Is going to be very exciting for that portion. And I'm also going to share some thoughts about the future hardware development for AI. Finally, I'm going to share something personal interest, which is beyond the technology. So first, let's take a look at the big picture. Okay, for the past 50, 60 years, IT industry started with the mainframe and terminal, and later on we have lots of PC. So therefore, the infrastructure become client server. Some people have that experiences, some people don't because you might be too young. Nowadays, we are living in the cloud world, right? So we have mobile and cloud. What's next, right? Because the explosion of the data and make this happen, we have 5G coming up in the picture. We have IoT devices, especially the industry IoT. And in 2021, there will be 50 billion connectivity of the IoT. So those kind of demand emphasize the needs of edge computing. I think previous speaker also mentioned edge computing is very important because cloud is too far. We've got to have something in the real time and close to the end devices. And why AI is associated to that? If you look at the AI history record, you will find that the AI is really attached to the IT infrastructure and architecture revolution. You can say it's a limitation, or you can say it's helping each other. So nowadays, modern AI, we're talking about machine learning, actually is very simple. You train the machine in the cloud, and you do the inference at the edge. So no doubt, AI and machine learning is facilitating the rise of the new IT infrastructure. So let's think about or looking into the a little bit narrow portion. What is machine learning? It's an iteration cycle, just like our human education. You learn something, you do something, and you feedback, and then you continue to learn it and make you better and smarter. So first part of the portion is, I say, big data, right? So because today, internet is a wonderful resource. You can get all those data, any kind of data. And you prepare for the training material. You fit into the model, you prepare, and then make the model become capable to do the inferencing to the level that you feel is good, position level. And then there's a feedback cycle, okay? So basically, we train the machine, let them graduate, and then they can do some inference for us, and they eventually do some more work. Finally, they might be able to make decision for us. So this is a cycle. What is the process of machine learning then? So as I mentioned previously, I personally feel there are three big things at least we need to take care, or three phases. The first one is big data. Right? We need to do some data mining, data analytics, and also we call it prepare for training material. And then we move on to the training process. Once you have the data and you have preset model, these two join together and then do the training portion. Make this model become trained, which means it can be inferencing in a very precise way. So finally, there's the inferencing. These three phases require very different hardware because they have different characteristics. Now, it doesn't matter which one. The basic foundation is still you're facing three things. One is compute, storage, and networking. Let's take a look at the compute first. today, when we're talking about the training, CPU is no longer sufficient because they build for general purpose. Now, in an AI application, you got to have something special just for the training purpose or for the inference purpose. So that's very different from traditional server. So therefore, we need accelerator. Could be GPU, could be FPGA, could be any kind of acceleration card built for the purpose. Second portion is storage. You can see we have cold, warm, hot storage. This is a tier level storage, just like traditional IT. A couple of things I want to pay attention on. Number one, 3D NAND become more mature. So the NVMe all-flash solution for sure going to be the future trend. The other technology you want to pay more attention is the persistent memory. No matter how fast SSD will be, it still have a gap from the memory. So why not make the memory become the storage? So that's why persistent memory become very important research topic today. So soon it will become popular. So that all will accelerate our AI and machine learning process. Finally, the networking, the progression is to continue. So today, 10G on board is very normal. Now we're also talking about 25G. And at the backbone, we have 100, 200 gig, and no need to mention those high-speed interconnect, InfiniBand or OmniPass. So continue to progress. All those you can find in Supermicro, also in other company. The key is that how do you make the combination to serve the purpose for big data, or for the training, or for the inferencing. Let's take a look at 3 of this one by one. The first portion, big data. Right, big data being with the technique being with us for many years. What is the first thing come to your mind when you look at big data? Hadoop, right? Because Hadoop been here for so many years, and it's open source. Everybody talking about Hadoop, and there's a variation, right, similar to Hadoop. So actually, many companies became successful because of Hadoop. Nowadays, Hadoop is so commoditized, and it's a turnkey solution. So those companies need to go up 1 or 2 levels. So they say they are data analytic company associated to the AI now. So those kind of things is mature technique. Second portion I'd like to see is inferencing side. I leave the training at the last because I feel training is the most exciting portion. Inference is important because inference requires immediate response, and therefore has to be lightweight, networking very good, and then you might want it to have built-in 5G because this is a real-time processing. Cloud is too far, edge is application specific. For example, in a stadium, 30,000 people watching the football game, right? You got to have something close to the edge devices. And these edge devices are intelligent enough to understand your personal preference. So they will show those players as you like and automatically provide those information that they predict you want. Something like that. Finally, let's look at the training portion. Well, lots of research and development on the training side because training sometimes is very difficult. Okay. In the past so many years, as I mentioned, we have a lot of researchers, scientists, developers, all kinds of models for training. Some example, recent year, we have lots of image processing. Right? So you can see there's a neural network called CNN, convolution neural network. So the computer can recognize the object. millions of data need to process. So it's very, very computational intensive. Each image, bit by bit, to try to find a pattern in order to recognize the object on the image. So let's talk about this a little bit more. Obviously, the CPU traditional IT equipment is not going to work well, right? So we need something more. For example, the GPU, probably the most hottest topic in this machine learning. Supermicro have many, many systems. Every time I show something, that means it's only a small portion. This is just an example. I want to show this because from the designer point of view, the topology is very important when you design the system. On the screen, you can see there's a flexibility type of design because that's a PCIe card. You can add in as many as you want, different cards you want. On the center and the left-hand side, right-hand side are the performance because they don't have the PCIe bottleneck. They're using the NVLink to do the communication. Right. So let me give you one example why the topology design is so important. In this system, very typical, right? You have two CPU, you have a bunch of GPU, and then intuitively thinking, you can design symmetrically, right? What each one CPU take care, like in this case, 4 or 5 GPU. So it's very symmetric. For some application, this is fine because they do the CUDA programming exactly mapping to this. But in many cases, we found people wanted to use GPU system because they want to take advantage as much as they can on the GPU communication. So there will be a lot of communication going on from the left-hand side to the right-hand side. In that case, when the GPU on the right wanted to communicate to the left, it will go to the CPU, right, with the two more hubs. So create a lot of latency. Therefore, we have another solution we call a single root complex design. So all the GPU will hang on one CPU. So you can see clearly the results of the latency testing. So the latency winner will be on the same root CPU complex design. Because when you have communication between left to the right, if you go to additional hub to the CPU, you create latency. This slide, I want you all to take a picture. I feel it's very exciting because this is the latest generation of training machine for machine learning or learning machine. It just announced last week at GTC Taipei. How powerful is this machine? This machine has 16 volta, interconnect by 96 NVLink, and in between is a so-called NV switch, high speed, high performance switch. So this is a co-design and development with NVIDIA. So it can deliver, a single system, deliver 2 petaflop. Right, it's unheard. If today you wanted to make a 2 petaflop cluster, right? So HPC people, I'm sure you understand, if you're using CPU only, probably you need a few thousand nodes, and then maybe 15 to 20 racks. Even you have GPU inside, you can reduce to maybe 3, 4 racks still. It costs you probably $10 million, right? So in this case, just one machine. So obviously, this is designed for scale-up type of training machine. So back to the training portion. Of course, in the data center, I mentioned that training usually performed in the data center. And data center have so many models need to be trained, so many information need to be stored. Maybe one machine is not enough. Then you need a cluster of the machine. So scale out still needed. In this case, you can use in factory topology. And this machine can give you 8 by 16 PCIe Gen 3. So you can have 8 InfiniBand, so reduce the bottleneck of the scale out. Not necessarily every training has to be using GPU. If you have very small model, CPU might be good enough. So the other design methodology is thinking about maybe scale out kind of device. Scale out means not packing all the performance resources into one system, but using multiple smaller systems and put it together, become we call it appliances. For example, this is a blade solution, 20 blade. Each blade can be a 2P Xeon, or it can be so-called nice landing, nice quarter, nice male processor. And it can be mismatched, depends on your application. So this is a more like scale-out design, and the 20 nodes actually interconnect with the built-in high-speed switch, InfiniBand or OmniPass. So let's think about the future. So all those architecture we're talking about is current technology. There's something in the future, right? It's actually happening. Doesn't matter we call it scale out or scale up design. They're all limitation, right? There's a PCI limitation. There's a interconnect limitation. So people are starting looking into the AI-specific chip design. Right? NVIDIA GPU, for sure, they will continue to improve. Intel is not resting. They have Lemana. They call it Spring Crest. Just announced 2 weeks ago. Probably it will be available at the end of the year. And also Google, interesting, is a TPU, TensorFlow Processor Unit, just designed for the training model. And then there's a DPU. DPU is also interesting because CPU is a compute-centric. DPU is the data-centric. When you do the training, mostly it's the data movement, comparison, things like that. So DPU will come to the picture as well. FPGA for sure. FPGA in the past, people are scared to use it because it's very difficult to program it. Nowadays, people have well-designed model for AI. You can just adopt it and then put it into the FPGA. That become your personalized training machine or inferencing machine. Okay? Final thoughts. I don't know how many time I have. Anybody in the room heard about the trolley problem? Trolley problem. Some, right? So it's a problem of discussing about ethical or legal or morality in the 1960 time. So I think it's 1967. So the story is that a trolley, right, out of control, high speed, and it will kill 5 people if continue on the way. There's an operator on the side. The person have a choice. He can do nothing and kill those 5 people, or he can quickly switch the gear and turn into another route and kill just 1 person. So if he chooses to do that, will he be a killer or a hero to save those 5 people? So this is an interesting problem, but there's no perfect answer. So going forward in 2020, the situation getting worse because the decision maker is not human being, it's going to be the machine. The machine will say, for example, in this case, the machine predict that continue go to the route and there's a problem on the road, fall out the cliff. So in order to protect those people on the train, and he have to have one choice to turn it over and then kill somebody on the road. So who's going to take the responsibility? Right, the machine or the developer or somebody else? Think about this. A few years later, you and I are going to have a self-driving car. What is the first priority of the self-driving car of yours? The car going to protect you and your passenger as the first priority. And in some situation, it's a conflict. right? The car might be harmful to somebody else on the road or other cars in order to keep you safe. In that situation, what would be happen? Who would take the blame, right? So this is an interesting but very important discussion. I think as a industry or community, we need to come together, continue to look into this problem because AI will pose new ethical dilemma to the human being society, for sure. Okay, with that, I conclude my presentation for today. I thank you for listening. Thank you.
Thank you very much for joining us this afternoon, Dr. Leung. And with that, we conclude this afternoon's forum on artificial intelligence. 我们今天下午的议程到这边圆满落幕了。我们能够提醒您，请您用您的手机来扫描您的名牌上面那个 QR code， 帮我们填写线上问卷，可以到我们1楼来兑换杂志。我们也请您在出场的时候，将您的名牌交还给我们在现场的工作人员。我们提醒您，您现在身上所佩戴的名牌，我们将会进行回收。您可以在出场的时候就交还给我们站在我们会场出口两旁的工作人员。Ladies and gentlemen, the forum tomorrow on future trends will begin at 9 o'clock and doors will open at 8:30. 我们明天有关 Future Trends COMPUTEX Forum 明天早上的论坛将于早上9点钟正式开始，我们将于早上8点半开放大家进场，谢谢。